Hello, myself P. Kaushik Reddy from CACA, and my roll number is 2295180570, and my tech talk topic for artificial neural network, that is ANN, for the subject artificial neural network ANN. Topic 80 tech talk topic is online and incremental learning in neural networks. So let's get started. So yeah, first the introduction. Online learning. Online learning is a training approach where the model learns from one data at instance at time, updating itself instantly with each new input. It is memory efficient as it does not require the entire data set and is well suited for the time continuous data environment like streaming. Its fast and adaptive nature, making it ideal for applications quickly responses to data changes. Incremental learning, on the other hand, involves updating the model gradually using small batches of new data without retraining from scratch. It is designed to retain prior knowledge by learning from evolving patterns, making it suitable for non-stationary environments. This method also supports model growth, allowing neural networks to adapt structurally as new data is introduced. So the use cases. So online learning, real time, one instance at a time. Stock market prediction needs instant updates at as each data point arrive. IoT sensor monitoring, continuous data stream requires real-time update. Autonomous vehicle learns and adapts to changes in environment instantly. Incremental learning, batches over time, retains past knowledge. Personalized recommendations. Learners learns user preferences from session over time. Smart home systems gradually adapts to long-time behavior patterns. Healthcare monitoring device updates models based on new but infrequent data. Example, patient records. What is online learning? So online learning is a machine learning approach where a model learns from data one instance at a time, updating itself incrementally as a new data arrives. Unlike the traditional batch learning, where which process the entire dataset in one go, online learning handles the data point individually, making it ideal for applications where data is converted or generated or streamed in real time. This method is particularly effective in where storing large data sets is impractical or where decisions must be made quickly, such as in financial trading, recommendation system, or sensor monitoring. Because it does not require retaining the full data set. Online learning is memory efficient and can operate on devices with limited computational resources. Additionally, the model can adapt rapidly to changes or patterns in incoming data, which is especially useful in environment where data distributions evolve over time, such as user behavior or environmental sensors. However, one of the key challenges with online learning is ensuring the model remains stable and does not overfit to recent data, while still being flexible enough to the model remains stable and does not overfit to recent data while still being flexible enough to learn new patterns. Despite this, it remains a powerful tool for real-time adaptive systems, enabling continuous learning and model improvement without full retraining. Retraining. What is incremental learning? So incremental learning is machine learning strategy where a model is trained to learn from new batches of data over time while re retraining knowledge gained for earlier training, unlike traditional batch learning that requires the entire data set to be available and the model from scratch whenever new data is introduced. Incremental learning allows the model to evolve continuously. This is especially beneficial in scenarios where data is collected gradually and the underlying patterns may be changed over time. Key advantage of incremental learning is its ability to avoid catastrophic forgetting, a problem where models forget previously learned information when trained on new data. By preserving past knowledge, it ensures consistent performance even as the model adapts to newer inputs. And this approach is ideal for non-stationary environments such as a user behavior analysis, medical diagnosis system, of fraud detection, where data patterns shift gradually over time. Incremental learning can also reduce computational costs since it eliminates the need to retrain models from the beginning. Techniques such as regularization, rehearsal, memory replay, and architectural adjustments are commonly used to support this learning method. Ultimately, incremental learning promotes scalability and long-term adaptability, making it essential for systems that must learn continuously and evolve over time. Differences between online learning and incremental learning. The differences, the comparison between online learning and incremental learning are based or showed on the basis of data input, model update, storage requirement, adaptability, training efficiency, knowledge retention, use case suitability. First, the data input. One data instance at a time in the online learning, and small batches of new instances are in incremental learning. Model update in online learning is the instantaneous updates, and incremental learning, periodic or scheduled type updates. Storage requirement in online learning is minimal, does not store past data. In incremental learning, it's moderate, may need to store some past data. Adaptability in online learning is high adaptive to immediate changes. In incremental learning, adapts gradually to evolving data. Training efficiency in online learning is very fast and lightweight. In incremental learning, it's efficient but slightly more resource and intensive. Knowledge retention in online learning is mere risk for getting older data, and incremental learning redesigned to retain past knowledge. Use case suitability in online learning is real-time system, streaming data, and incremental learning is system with periodic updates, evolving patterns. Applications, online learning applications, spam filtering, adapts to new spam tactics instantly. Stock price prediction, reacts to real quick time market changes. Recommendation system, updates suggestions based on liver user behavior. Incremental learning applications, medical diagnostics, learns from patient history and new medical data. Handwriting recognition improves accuracy over time with user feedback. Language learning apps adapts to individual user progress over sessions. Algorithm used. Algorithms like stochastic gradient descent, passive aggressive algorithm, and adaptive resonance theory and evolving neural networks. These are the algorithms used. So, stochastic gradient descent is used in online learning, and explanation for that is updates model weight, each instance fast and suitable for real-time applications. Fast aggressive algorithm used in online learning, and its explanation is updates only on errors, making it ideal for high speed streaming classification. And adaptive resonance, and it is used in incremental learning, and explanation is maintain stability and plasticity, cluster evolving, and data without forgetting. Evolving neural networks used in both like online and incremental learning. Explanation is and adapts structure over time, supports both the instance-based and batch-based updates. Online neural networks. Learning in neural networks refers to a training approach where the model is upgraded continuously, typically after receiving each individual data point, unlike the batch learning. The entire data set at once. Online learning enables the network to adapt quickly and efficiently as information as it arrives. This leads to lower latency in model response and is particularly used at the time applications such as streaming data analysis, autonomous system, or fraud detection. A key feature of this method is used to of stochastic gradient descent. Their model weights are updated after processing each new sample. This enables the network to improve incrementally without waiting for an entire data set or large batch. As a result, online learning supports dynamic model tuning, allowing neural networks to adjust their parameters in response to evolving data distributions. This capability makes online learning especially valuable in non-stationary environments where data patterns change over time. However, it is also introduces challenges like increased sensitivity to noisy data and the risk of forgetting older patterns. Despite these issues, online learning remains a powerful approach for building adaptive, fast, and memory-efficient neural network models capable of operating in real-world, continuously changing systems. Incremental learning. Incremental learning. Incremental learning in neural networks refers to the ability of model to learn new information with the so that the time without losing previously acquired knowledge. This approach is particularly important in the world applications where data arrives gradually or changing over time, such as healthcare and user personalization systems. A major challenge in incremental learning addresses is that the underlying data distribution evolves. Traditional models often struggle with this, requiring retraining from scratch, which is computationally expensive. One of the key goal in incremental learning is to avoid catastrophic forgetting, a phenomena where the model loses performance on earlier learned tasks when trained on new data. To overcome this, several techniques are employed. Regularization methods such as elastic weight consolidation constrained important weights from changing significantly, preserving older knowledge, replay-based approaches used stored or generated samples from previous data to retrain the model alongside new inputs. Additionally, dynamic architectures allowing the network to grow or modify its structure to accommodate new tasks without interfering with old ones. Incremental learning enables long-term adaptability, making neural networks scalable and resilient in dynamic environments. It is a key component in building systems that can learn continuously, just like humans. Challenges in online uh, challenges in online and incremental learning are stability versus plasticity trade-off, balancing the ability to learn new information plasticity without losing previous knowledge. Stability is difficult. Forgetting older knowledge, models may unintentionally override or ignore earlier learned patterns, leading to catastrophic forgetting. Overfitting to recent data. With continuous updates, models can become biased towards the most recent inputs, reducing the generalization computational efficiency. Although more memory efficient, frequent updates and replay mechanism can increase processing load over time. Techniques to address these challenges. Regulation methods, example EWC and LWF, prevent important weights from changing drastically to preserve previously learned knowledge and avoid forgetting. Memory replay, generative or raw samples, reintroduce the past data or real or synthetic during training to maintain an old performance task. Modular neural networks use separate network components for different tasks or data distributions, minimizing interference between old and non-knowledge. Dynamic architecture, expanding or reconfigure the network structure as new data arrays, allowing adoption without overwriting the old patterns. These are the real-world case studies in the field of autonomous driving. Self-driving vehicles rely on incremental learning to adapt to new environments and road scenarios. As these vehicles encounter unfamiliar traffic patterns, weather conditions, or obstacles, they update their neural models to enhance safety and performance without needing to complete retraining. Real-world case studies demonstrate how online and incremental learning is essential for building adaptive intelligence system. For example, Google Assistant used for online continuous adaptive user voice. And another strong example is the facial recognition system, which must recognize individuals as they age or as their appearance changes. Incremental learnings enables these systems to gradually integrate new facial data while retaining existing identity mappings, ensuring reliable long-term performance. These case studies highlight how online and incremental learning empower. To the conclusion, online and incremental learning are powerful approaches that enable, say, a system to write real time or over time, making them highly efficiently in environments with continuously evolving data. By updating models dynamically or incrementally. This makes method eliminate. They are essential for applications like monitoring, personalization, adaptive controlation system. Despite the challenges like forgetting and stability, advanced techniques such as regularization, memory replay, dynamic architectures offer practical solutions. The future of this field lies in lifelong learning and continual learning networks that mimic human-like uninterrupted knowledge acquisition. So yeah, this is my 80 technical topic for ANN, that is artificial neural networks. Thank you.